We're starting our quiz review. All right, we're going to be doing a quiz today on sections 3.3, 3.2, and 3.4, covering the power rule, velocity and acceleration, and the product rule for differentiation. All right, we'll start with section 3.3. Now this is the power rule. It says that the derivative of x to the n is n times x to the n minus 1. So let's look at a couple of examples. All right, let's say we have f of x is equal to 3x to the 5th minus 2x to the 7th plus 10x, let's say, plus 5. All right, so here's the derivative. Now we're also using not only the power rule when we take this derivative, we're also using the fact that the derivative of a sum is the sum of the derivatives, so we can take the derivative each term, one term at a time, and also the fact that we just leave the constants in front as we take the derivative. All right, so let's do that. So we'll take the derivative term by term using the power rule. We'll leave the 3 in front. So the power rule says bring down the 5 and subtract 1 from the exponent. 5 times 3 is 15, and subtract 1 from the exponent. So that's the derivative of the first term, and now the second term. 7 times 2 is 14, subtract 1 from the exponent. All right, here we have a linear term, x to the 1. We can use the same power rule, bring down the 1, change the exponent to 0, which leaves us with 10. Or just think of this as a line with slope 10. The derivative is the slope. Okay, 5 is, think of that as a horizontal line. Y equal 5, the derivative is 0. So the derivative of a constant is 0. Anyway, this is f prime of x, and we just use the power rule to find the derivative here. Now, let's do one more example. All right, this time we'll have to manipulate f of x a little bit before we can apply the power rule. Okay, so let's say that f of x is equal to, let's suppose we have the square root of x in the denominator, and let's say we have here 2x squared plus 5. Now, this is not written as a sum of powers. We have to put it in that form, right? F of x as a sum of powers before we apply the power rule. So f of x is equal to 2x squared plus 5, and I'm just going to rewrite, instead of square root of x, I'll write x to the 1/2. And now I'm ready to split this up into two powers. We're going to first divide 2x squared by x to the 1/2, and we have 2x to the 2 minus 1/2. That's 4 halves minus 1/2. 1/2 gives us 3 halves. Plus 5 divided by x to the 1/2. That's 5 times x to the minus 1/2. Okay, so that's just f of x rewritten. Here, let me put f of x here again. That's really f of x rewritten. And now we're ready to find f prime of x. Let's do that using the power rule. So here, bring down the 3 halves. 2 times 3 halves is 3. X to the 3 halves minus 1. That's 3 halves minus 2 halves. That's 1/2. Now, bring down the minus 1/2, multiply by 5, so we have minus 5 over 2. X to the minus 1/2 minus 2 halves, that's x to the minus 3 halves. And that's f prime of x. Okay, so now you're ready to do the first problem on the quiz, and here it is. Here's problem 1. Okay, so just, you can pause the video and copy this. Okay, now we're looking at section 3.2, which talks about distance functions, velocity, and acceleration. All right, so let's suppose s of t is a distance function. That is, s of t measures the distance traveled by an object after t units of time. All right, so we have the average velocity from t equal a to t equal b, and that's equal to the distance traveled from A to be, that would be S of B minus S of A. So this is distance over that time interval, which is B minus A. So basically this is distance over time, and that's average velocity. So we had this formula. And then we also saw that the velocity function, sorry, let me just get rid of this little tick mark. Okay. The velocity function is equal to the derivative of the distance function. So that gives us the velocity at a specific time. And also the acceleration is the derivative of the velocity. Okay. So let's do an example that'll be similar to example 2. All right, in this example, we have the following function. Okay, here's the function. Distance function, S of t, is equal to 3 times the cube root of t plus t. All right, and what we want to find first is, let's say in part A, we want the average velocity from t equal 1 to t equal 8. So that's S of 8 minus S of 1 over 8 minus 1. All right, so that's equal to 8 minus 1, that's 7. S of 8, substitute in 8 over here, and we have 3 times the cube root of 8, that's 3 times 2, plus 8, that's S of 8, minus S of 1, that's 3 times 1 plus 1, that's just 3 plus 1. 3 plus 1, which is 4. Okay, so what do we have here? So that's equal to, this is 6 plus 8, that's 14. That's 14 minus 4. So we get 10 over 7. So that's the average velocity. All right, and then let's suppose we want the velocity at time t is equal to 1/8. All right, so then we need to find v of t. Well, before we find v of t, we are going to, well, to find v of t, we're going to differentiate s of t, and let's just rewrite it in with the cube root of t written as t to the 1/3. So let's write s of t is equal to 3t to the 1/3 plus t. So we're writing it as in power form so we can use the power rule. So then v of t is the derivative. That's 3 times 1/3 is 1. Okay, so we have 1 times t to the 1/3 minus 1. 1/3 minus 3/3, that's minus 2/3. Plus the derivative of t, which is 1. So now we want the velocity at t is equal to 1/8. So let's just substitute in 1/8. So we're looking at v of 1/8. So that's equal to 1/8 to the minus 2/3 plus 1. And that's 8 to the 2/3 plus 1. Right, the cube root of 8 is 2. 2 squared is 4. 4 plus 1 is 5. So the velocity is 5. Now we're ready to do question 2. So here it is. Here's question 2. All right, so pause the video, copy this down, and do this question. Let's look at the next example. All right, we have a ball is thrown down from a window. The distance from the ground is given by s of t equal minus 16t squared minus 48t plus 160. So in part A, we want to know how long does it take for the ball to reach the ground? Okay, how long? That means we want to find out how many seconds. So we're solving for t. Now, what are we solving for t? Well, when the ball reaches the ground, the distance from the ground is 0. So we're solving s of t equal to 0. So we're going to take S of t and set it equal to 0. All right, this minus 16 does factor out of the coefficients. And we're left with a quadratic in parentheses that does factor. All right, so we have t is equal to minus 5 and t is equal to 2. And we reject the negative time values. All right, so t equal to 2 seconds, that'll be the amount of time that it takes for the ball to reach the ground. All right, now in part B, we're going to be, we are asked, what is the velocity when the ball hits the ground? And you can think of this as the instant before the ball hits the ground. Of course, once the ball touches the ground, the velocity changes. But we're talking about the instant right before it touches the ground. So that'll be given by v of t, velocity function, which is the derivative of the distance function. So just taking the derivative of s of t, we have minus 32t minus 48. And we want to know what's the velocity when the ball hits the ground. Well, the ball hits the ground when t is equal to 2. So we're going to substitute in t is equal to 2. So we're going to find v of 2. It's minus 32 times 2 minus 48. Okay, and that's equal to minus 112 feet per second. Okay, now you can do the next problem. All right, that's problem 3. So here's problem 3. Actually, I see here problem 3 asks also for the initial velocity. The initial velocity, take the velocity and substitute t equals 0 to find the initial velocity. So that would be v of 0 for part A. Okay, so copy this down, pause the video, copy this down, and do question number 3 now. The next example is also a vertical motion problem of a free-falling object. In this problem, we have a projectile, that's like a rocket, is shot from the ground straight up into the air. Its distance from the ground is given by the following function. S of t is equal to minus 16t squared plus 80t. Notice when we put in t equals 0, we get 0 because its distance from the ground is initially 0. It's starting on the ground. Okay, so part A. After how many seconds does it reach its maximum height? All right, the picture looks like this. Let's say this is the ground. So you have a projectile coming out of the ground, being shot out of the ground straight up into the air. It's going to reach its maximum height, and then it's going to turn around and come straight down again. So it's going to go up, turn around, and come straight down. So we want to know after how many seconds does it reach this maximum height. All right, so when it reaches its maximum height, the velocity is 0 because as it's going up, the velocity is positive because the distance is increasing. Then as it's going down, the distance from the ground is decreasing and the velocity is negative. So in between, the velocity must be 0. So at the height, the velocity is 0. All right, so what we're going to do is we're asking when is v of t equal to 0? That's when it reaches its maximum height. All right, so we know that v of t is s prime of t, which is, just differentiate this, minus 32 t plus 80, and set it equal to 0. So we have minus 32t is equal to minus 80. T is equal to minus 80 over minus 32, which is 5 over 2 seconds. That's 2.5 seconds. 5 over 2 seconds. So that's when the projectile reaches its maximum height. So that's the answer to part A. And in part B, we want to know what is the maximum height. So this is going to be given in feet. All right, so this is really, we're asking what is s. S is the function that gives us feet, the distance function. So we want to know, what we're asking is what is s of 5/2. Just plug in when the amount of time it takes to reach the maximum height into that distance function. So here we have s of 5/2. That's equal to minus 16 5/2 squared plus 80 times 5/2. Okay, so that's minus 16 times 25 over 4 plus, I'll divide the 2 into the 80, we get 40. 5 times 40 is 200. Divide the 4 into minus 16, we get minus 4. So here we're going to get minus 100 plus 200. This is 100 feet. So the maximum height is 100 feet. Okay, now you can do the next problem. Let me show you. Here it is. Problem 4. Okay, so let me give you that problem 1 second. Let me just show it to you. Oops. Okay, here we go. Okay, there we have problem 4 right there. Just ignore that blue line. Okay, okay, so copy down problem number 4.